Hello, my name is Roland Richardson, and today I want to talk to y'all about artificial intelligence. I know AI can be really intimidating for sure. There is currently a lot of hype surrounding it, and I personally think people can lose their way and they jump straight to advanced algorithms. I need people to see that AI is an infrastructure problem first and an algorithmic problem second. I love the way data scientist Monica Rogati explains this because she uses a hierarchy of needs to explain how this all works. I enjoy how she shows that organizations need to secure their basic survival needs first. She says, think of AI as the top of a pyramid of needs. Yes, self actualization, AI, is great, but you first need food, water, and shelter. Data literacy, collection, and infrastructure. Rogati, 2017. I think this is very true because layer 1 infrastructure and data is absolutely the bedrock for all of this. I enjoy thinking about raw business data as the essential food and water to nourish analytical engines, and I also like how cloud storage and automated data plumbing provide the shelter to keep operations very stable. I know setting this up can be kind of hard, but I believe establishing a robust data foundation is absolutely critical. I personally feel it acts like a circulatory system and a skeleton for your technology. I think no advanced AI application can survive or generate business value without it. I absolutely love reading her work called The Data Science Hierarchy of Needs, published by HackerNoon on June 12th, 2017, so much. Now, I want to look higher up in the image at layer 2 structural architecture and neural networks. I know building business value with artificial intelligence can feel absolutely intimidating for sure, but I really think we can understand it together. I think people sometimes get confused and they believe intelligence just spontaneously emerges by pouring their raw corporate data into training algorithms. I wish it were that easy for sure. I like to remind everybody that we absolutely must build a structural framework to connect the data and the algorithms because that is our second layer called the structural architecture. I enjoy reading Charu C. Agarwal so much. I want to share his exact quote because he explains that the neural network abstraction can be viewed as a modular approach of enabling learning algorithms that are based on continuous optimization on a computational graph of dependencies between the input and output. Agarwal, 2018. I love how this layer functions as a digital circuit board and a structural blueprint of your system. I think engineers assemble very standardized and interchangeable building blocks of computing nodes, and I really love that process. I know it is kind of like an architect stacking specialized floors to construct a bridge that routes data into high-level insights. I do not want anyone to lose track of the fact that this structural architecture does not learn on its own. I just think instead provides a very finely engineered racetrack for algorithms to run continuous optimization across its nodes. I absolutely believe that form dictates function in AI so much. I want to tell y'all that investing in the right modular architecture is essential because it dictates how deeply, accurately, or rapidly your systems can learn from your foundational data. I love that this foundational data can then power your end user applications. I enjoy his book Neural Networks and Deep Learning, a textbook published by Springer in 2018, very much. I next want to move up to layer 3 learning methodologies like machine learning and deep learning. I know extracting value from corporate data to build true business intelligence can be kind of hard, but I really love learning about it. I know the raw data is just the fuel for sure. I like to picture our structural architecture as the static circuit board because our third layer is the dynamic engine room that drives the entire active stack so much. I want to share Stuart Russell and Peter Norvig's ideas where they explain that we can think of supervised learning as a search through the space of hypotheses for one that performs well, even on new examples. Russell and Norvig, 2020. I absolutely love finding the right answers. We measure performance using a loss function, and learning inside deep neural networks is formulated as an optimization problem. We want to find the set of weights that minimizes the average loss over the training set. Russell and Norvig, 2020. I think this optimization process sounds very useful. I really like to imagine the second layer as a massive sound mixing board with billions of connection dials, and I believe the third layer is the master audio engineer. This layer navigates hypothesis space because it systematically measures errors and continuously refines those structural dials until the operational noise disappears entirely. I love being able to reduce errors in my models. I personally think this third layer is the essential transformation engine, and it bridges the gap in your technology stack by turning inert infrastructure into high accuracy intelligence required to power end user applications. I absolutely love their book, Artificial Intelligence, A Modern Approach, 4th edition, published by Pearson in 2020. I finally want to reach the very top of our diagram to discuss Layer 4 applications and interfaces like generative AI and large language models. I know getting a return on investment from your artificial intelligence infrastructure can feel kind of hard for sure, but I absolutely love seeing how the technology bedrock just powers this final layer. I enjoy learning about this so much. I personally like reading David Foster, because he explains that generative AI is the hottest topic in tech, and it brings a profound paradigm shift. Foster, 2023. I agree with him absolutely. I think his book, Generative Deep Learning, is very amazing. I love his exact words because he says generative modeling focuses on understanding how a data set is generated and is characterized by its probabilistic nature. Unlike discriminative models, which predict labels from data, generative models learn the underlying rules of a dataset to generate entirely new examples. It's now possible to teach a machine to excel at human endeavors, to paint, write, compose, and play. Foster, 2023. I love that machines can create new things now. I really like to imagine our data infrastructure as foundation and our algorithms as an engine room, because this fourth layer is like a sleek executive penthouse with floor-to-ceiling windows. I wish I had a penthouse, oh my goodness. I love nice windows. I know it is cool how complex models are transformed into intuitive, interactive tools, and I absolutely enjoy using conversational chatbot screens, text prompt boxes, or interactive code editors. I think we can collaborate with machine intelligence very easily. I do not want anyone to lose sight of how employees across every department can use their interfaces to instantly draft reports or compose software code, and I know this turns your deep infrastructure investments into immediate productivity gains. I think that is very cool. I absolutely love enterprise-wide productivity so much. I think his book, Generative Deep Learning, Teaching Machines to Paint, Write, Compose, and Play, published by O'Reilly Media in 2023, is really great. That is my presentation, and I thank you for your time.